What's up, YouTubers? It's Johnny Valentine with Gain Solar. Got us a little battery change out today, and I'm here at a secure location. This is something I see more often than you want, but this is a secure location somebody developed, and then something happened, they lost it, sold it, but there's plenty of preppers out there.
So this is kind of a situation where we're doing a little bit of forensic solar. We're trying to figure out what exactly they've got. Cool spot though, shipping container, well-built building, spot for toys. So now I'm going to figure out what all these switches and levers go to.
We basically have a steel job box with two 3648 outback inverters installed on the top and a Flex Max 80 charge controller. And underneath that is where the battery is. So when you see Antonio working, he's lifted it up and he's working on the battery underneath.
Antonio's taking loose these batteries. Pienso que van a salir unas buenas de esos. Unos de esos son buenos. Porque ya encontramos el malo. And this is a trademark evidence of a overcharged battery. That's what happens when you don't use plenty of water, but she's got a little plate growth. We're going to be swapping these batteries out, putting in a set of AGMs, and I'm trying to figure out what's going on here. So I'm going through now and I'm just figuring out what goes where. This is a transfer switch, and it's a ROC transfer switch. There's nothing landed in the two aux terminals, but it does make a cool noise and do a cool thing. I love the transfer switch. The transfer switch is nowhere. This is your solar, and there's two sets of cables coming in here. One set of cables is for an RV outlet. That's an RV, or a dryer, if you want a dryer out here. And this set of cables is for your solar disconnect. So your solar circuit is coming down here, it's going through this disconnect, and then it's feeding back into the electrical panel. We're cleaning nasty battery cables, just taking a little bit of hot water, dipping them in, pull them out, and they usually come pretty clean. That's your trick for the day. So we got our batteries changed back out. These Trojan Solars are going to do a lot better in a float application, this is a backup system, so these just kind of sit. And now we're going to just make sure all the programming is good on the inverters. So this is basically an AC coupled system. What we have here is a panel powered by the grid. This is grid into their transfer panel. And this is grid into the solar inverter. This is a relay that they're powering by either the grid or the solar output of the solar inverter that's breaking the wires going to the enphase solar array on the roof. That's about 7 or 8 kW. It's been pushing about 5,000 watts when we let it run. Right now I have one string on, and I'm waiting the 5 minutes for the other two strings to come on. And it's holding voltage pretty well, using most of the power in this. This is where the solar array ties in. But once the rest of the solar kicks on, this goes up to about 19, and battery voltage starts climbing. That's when things get interesting. And this relay, which is hooked directly to the battery, starts making something glow in the attic. And we just kind of changed that around the dump load. So we're waiting for current to really start flowing. And he's going to tell, when I see that go up to about 19, I'll ask him to let me know that it's glowing. We might get some footage of that. Now with this system, the batteries float charge at 54 and they absorb at 57.6. These are seal batteries, but it's because it's an AC coupled system. You're going to see this thing it doesn't have any really have any charge control to it. It's just going to dump the current that isn't used up in that panel. The AC current is going to flow backwards through the inverter and go through the charger onto the battery. So you're going to see a lot of current go into here, and you're going to see voltage spikes. So if it's up to 54, okay, so now voltage is going up. This is on. Is it glowing? We're going to let this, is it really glowing? 56 volts. So we got 18 amps from the solar array. 56, 56.7, 56.8. So I'm gonna head up into the attic. This is what we found in the attic. This is the dump load, and it's got the battery cables. Woo! Yeah, it's got a little power going through it. So this is a big old toaster. You need that in your house, don't you? Yeah. Just hook it straight up to the solar array. So this is cool. This is dangerous and fun and real barn burner. We just put this metal plate behind it. It was mounted to the wood, and the wood was all brown. So this is going to be the best way to control your solar array. What I recommend she do is just keep one of these on and kind of see where her voltage is hanging out. As long as you're between 50 and 57, you're good. But if you start seeing, you know, going up past 57 or kicking itself out, you're going to want to just cut a couple of these breakers off. Maybe just run with one of them on. If it's not sunny at all, you could run with all three on. This is kind of a thing where you got to play with it a little bit. This would be breaking your solar array up into 3 different strings. The black wire is the one going down to the disconnect on the outside. The yellow wires are going to the solar array on the roof. So what we basically have, we talked about, is a transfer switch that goes to nowhere. This is probably so that the homeowner can decouple from the grid. Then we've got the disconnect for the solar array, which solar power is coming down. And those yellow wires that you've seen before going through the disconnect, and they're going back into the electrical panel. That's just a convenience outlet for an RV or something. Then power is coming from the solar array. It's going through this relay that allows power to pass through if the grid or the solar inverter is on. You basically have to put 240 volts to here, and that makes that relay work. So if the grid or the solar generator isn't running, this relay closes, and that's so that you lock the solar array out when the generator's running. This is a transfer box, so grid power comes to here, and grid power goes to the solar generator, and then if it's either grid power or solar generator power, comes to that side, and this little interlock determines whether you're allowing grid power to pass directly through and feed this critical load panel, or you're allowing power from the solar, which could be passing through from the grid if the solar's in line, to go there. So this is kind of a bypass. These two wires right here come up through here and go into that. And they go into that via the top side of the transfer switch. The bottom side of the transfer switch would be where the generator is. We're not able to check the generator today and see if it's working because it's locked. But my supposition is the generator's in manual right now. The grid goes down, the generator comes on if you turn it on, and then it would make the switch, which would lock all this stuff out. The system is a little bit complicated. Ooh, she's got to be glowing now. I'm running up here right now to see this. Would you watch the battery voltage? Just look at that little thing and look at the battery voltage. Yeah, just call it out as it's getting higher.
58.
Are you gonna glow? Are you gonna glow? What's my meter say?
18.3.
So this thing's glowing. Man, this thing's heating. It's not glowing red though, like I wanted it to. I was hoping it would glow. Could hold some paper to it and watch the paper burn. But it's hot. I wouldn't. Okay, I'm done. Did it go down? Is the? That's good. That's good. I turned the solar off. Just 2 of them. Smells good too when it's heating up like that. A really good way to think about this is to call it a bypass. Basically, when it's like this, we're bypassing the solar inverter and all the grid power, or all the power from the solar inverters can go right into the grid. This thing's still got power to it, but it's just using that power to charge the batteries. So we're going to leave this as a solar generator backup power system and hope that this customer can manage the beast that is an AC coupled system during an outage. So the solar array is a grid tied solar array. This is a kind of a crazy concept here. But if you look at this array, I'll try to film it for you, or you can just take my word for it. There's micro inverters underneath there, and each one of them automatically takes the power from each panel and makes it into AC power, grid power. It comes down through this pipe, goes through this disconnect, and then it feeds into the electrical system through this relay and into this breaker. All that power gets used, and in normal operation flows back through, flows through there, flows through that breaker, down into here, flows through here, powers anything in here. If it doesn't get used, goes back through the grid and goes through that transfer switch outside and back into the grid. But when the power's out, this is off. The only way to turn the solar array on is to show, because it's a grid tied solar array, it has to see grid. If it doesn't see grid, you can trick it into coming on by bypassing grid and taking the solar inverter and allowing the solar inverter to present AC power to this panel. When it shows grid power to this panel, the solar array is going to wait about 5 minutes, and then it's going to start making power again. When it does that, that power is going to flow. It's going to make as much power as it possibly can, depending on how much sunlight there is. When that solar array comes on after its 5-minute wait period, it's going to make all the power it possibly can, dump it into this electrical panel. If it doesn't get used up in this electrical panel, it's going to flow backwards. It's going to go through the inverter. It's going to go into the inverter. It's not going to be able to go back into the grid because the grid's off. So where can all that excess power go? There's only one place it can go, and that's into the battery that I showed you. But when the battery's full, this little handy dandy device prevents the battery from being overcharged by dumping current into the dump load, which is a big resistive heating element that I showed you upstairs. Now, the best way to deal with not overcharging your solar array during a grid down scenario is to cut 1 or 2 of the breakers off upstairs so that not all that power is going through. See, 17 or 18, 20 amps is full current for the solar array. But if you break that up on 3 different breakers, that's 6 amps at 240 volts. It's cutting the array into thirds. And if she wants to run off grid, she might as well just run 1 unless she has a lot of load. It's an AC coupled system with a dump load, folks. And they work, but I don't recommend them. And lastly, we got one more for the album of solar panels in Georgia with pollen on them. She's got almost a 10 kW solar array.